we're going to talk about half-angle identities. Now, these are useful because these can help us find the exact value of sine, cosine, or tangent of an angle that may not be on the unit circle. If we know cosine of, or if we have cosine theta, sine theta, tangent theta, if those are like 45 degrees, 30 degrees, 60 degrees, or anything on the unit circle, we can just look on the unit circle and figure out what those coordinates are. But sometimes, say that we have like 22.5 degrees, that is not on the unit circle. But 45 is, and 22.5 is half of 45. So we could use this formula, well, any of these formulas, to find the sine, cosine, or tangent coordinates of that angle. So you're going to want to have these out next to you as you're working on your homework. Let's do an example. We want to find the exact value of cosine theta halves if sine theta is equal to -4/5 and theta is in the third quadrant. And I went ahead and wrote out the formula for cosine theta halves over here. So we know sine theta. To figure out cosine theta, we can do this one of two ways. We could either draw a triangle in the third quadrant of the axes and figure out sine and opposite over. This is opposite over hypotenuse. We could solve the triangle and find adjacent over hypotenuse for cosine. You could also use the Pythagorean identity, cosine squared theta plus sine squared theta is equal to 1. And we could plug in -4/5 for sine and solve for cosine. Let's go ahead and do it that way. So we have cosine squared theta plus -4/5 squared is equal to 1. So we get cosine squared theta plus 16/25 is equal to 1. Subtract that over. 1 is really 25/5, so 25 minus 16 is 9. So that's 9/25. And then we take the square root of both sides. We get cosine theta is equal to plus or minus 3/5. And so we need to figure out if it's going to be positive or negative. So if we look at our axes, we know that our angle is in the third quadrant, so down here. And we need to figure out if the x-coordinate, because that's what cosine is the x-coordinate, is positive or negative. So down here, the x's are actually negative. So our cosine of theta is equal to -3/5. Let's go ahead and plug this into our equation. So we'll have cosine of theta halves is equal to plus or minus the square root of 1 minus 3/5 over 2. And that'll be equal to plus or minus the square root of 2/5 over 2. And then we multiply top and bottom by the reciprocal of the bottom. So that's 2/5 times 1/2, because that's the reciprocal of 2. And we get plus or minus the square root of 1/5. Square root of 1 is 1. Square root of 5, we don't have an exact value for that other than a decimal approximation. So now let's rationalize the denominator. That means we want to get the square root out of the bottom. So we're going to multiply the top and the bottom by square root of 5. So we will get plus or minus square root of 5 over 5. Now we're not done yet. We also need to decide whether this is positive or negative. So we know that theta is in the third quadrant. So we know that theta is between 180 degrees and 270 degrees, because that's where the third quadrant lies. So to figure out where theta halves is, we basically can just divide this inequality all by 2. So let's see, 270 divided by 2 is 135. 180 divided by 2 is 90. So this angle is somewhere between 90 degrees and 135 degrees, which that's somewhere over here. So basically, theta halves is in the second quadrant, and then to figure out what the sine is, we look at the second quadrant. We're looking at cosine, so that's the x-coordinate, and the x-coordinate in the second quadrant is negative. So cosine of theta halves is equal to negative square root of 5 over 5.